For this presentation, we're going to go over transtibial bench alignment and kind of follow the process through to the final delivery or the definitive prosthesis. Before we start, we're going to do a few definitions. The first one is alignment. And alignment's the proper positioning or state of adjustment of parts as of a mechanical or electronic device in relationship to each other. So if we have one part on one side and one part on the other side, and they're 2 inches apart, that 2 inches is part of their alignment. So when we talk about alignment, we're talking about the positioning of two components to each other. And then we have a jig, and a jig is a device used to maintain the mechanically the correct positional relationship between a piece of work and the tools or parts of work during assembly. So what we're trying to do is we're making a device to hold the position or alignment of something we're trying to build or something we're trying to transfer or duplicate. So it's just a mechanical device to hold two pieces in position to each other. And then finally we have dynamic, and dynamic is basically continuous or productive activity. So when something's dynamic, it's moving. It's not just sitting still. So when you do a dynamic alignment, the patient's moving while you're doing the alignment. Then we have static, and static is standing or in one fixed place. So if we just have something in a position that's not moving, it's static. It's pretty simple. And then we have adjustable. And adjustable is to bring to a more satisfactory state. So whenever you hear something's adjustable, the purpose of the adjustments is so you can make it better. And that's what we do with a lot of our adjustable componentry in prosthetics, is that we adjust the prosthesis so it's better for the patient. So adjustability is real important for us in prosthetics. And then we have prototype. It's the original form that serves as a basis for later stages of fabrication. So that's what we do in prosthetics too. We don't just build the final prosthesis that the patient gets right off the bat. We first build a prototype prosthesis that we fit on the patient, we make adjustments to, we make changes to, so that when we make the final prosthesis, we can be pretty well satisfied that the patient's going to have a good fitting, well-functioning device for them to use. So the prototype in prosthetics is very important. So bench alignment is something we do in prosthetics that gives us a starting point. So it's basically a set of generic values used to set the relationship of components that make up a prototype prosthesis. So we have to have something to start with. We can't just have them walk on a prosthesis that has the foot backwards and sideways. We have to have a certain way of putting the prosthesis together so that it'll closely simulate what they're going to need when they stand up on it the first time. And so bench alignment is much like a recipe for chicken noodle soup. So if you go to the store and you buy some chicken broth, it may have a recipe on the back for a generic chicken noodle soup that it's okay, but it's not great. It's not the chicken noodle soup you want to eat. It's just something that you recognize as chicken noodle soup, and that's fine. But it still needs some spices and maybe some celery and some carrots and things like that to finish it off, to make it into some good chicken noodle soup that you really want to eat. So same thing with bench alignment. We're going to start off with a bench alignment value that's close so the patient can stand up, take a few steps, and then we can adjust it to fine-tune it and make it better during the dynamic alignment stage. And typically the components we use for bench alignment are very adjustable. And the reason that is so we can bring that prosthesis into a better state for the patient. So there's that adjustability definition. So after we've bench aligned the prosthesis and we've got it kind of in this generic form that everybody recognizes as a prosthesis and seems like it should work, we're going to then place it on the patient, have them take a few steps and do a dynamic alignment. So the patient's going to be moving. We're going to use those adjustable components then to adjust the prosthesis and bring it into a better state for the patient. So the practitioner is going to listen to the patient, and the patient may say, hey, I feel like I'm walking up a hill, or I feel like I'm walking down a hill. They'll adjust the prosthesis and make actual physical changes to it, and the bench alignment will then be lost. But that's okay because the new dynamic alignment is way better than whatever the bench alignment could have been. So we never want to go back to the bench alignment because after it's been dynamic aligned, that's the new patient's custom alignment for that prosthesis. So now I kind of want to give you just an overview of the entire process from casting to delivery, to kind of see where dynamic alignment and bench alignment and the transfer process fits in. There are a couple of good videos that you can watch. There's going to be one at the end that basically real quickly goes through bench alignment, dynamic alignment, and then the transfer process. But there's also a better video that we have, and it should be on your Blackboard course, that you can go watch, and it goes through the whole process very in-depth from the beginning evaluation and impression taking all the way to delivery. So I'd suggest that after this lecture, it wouldn't be a bad idea to go and view that other video. So the first process is casting. So during casting, the practitioner is going to take an impression of the patient's limb and record values that are needed for the bench alignment process of the prototype prosthesis. And the next one is bench alignment. So after all those values are taken, he's going to hand that off to the technician. The technician is going to take those values and take the impression, make a check socket, and build a prototype prosthesis. And you can see that the technician is actually aligning the prosthesis on a bench, doing a bench alignment, and he's using those generic values for bench alignment to do that. So after the technician has done bench align the prosthesis, he'll hand it back to the practitioner, and the practitioner is going to go and do a dynamic alignment. So the prototype prosthesis is going to be placed on the patient. It's not going to be perfect, but the patient is going to be able to get up and walk, and the practitioner is going to fine-tune the prototype prosthesis during the dynamic alignment phase. So they're dynamically aligning this. So the patient's asking or giving input to the practitioner, and the practitioner is asking questions to the patient. And within maybe half hour to an hour, they're going to come up with a really nice custom alignment that works real well for the patient. And that new alignment, the new dynamic alignment, is way better than the old bench alignment. So the old bench alignment is no longer necessary, and you'd never want to go back to your old bench alignment at this point. And the next phase is we have this prototype prosthesis now that's been dynamically aligned, fits the patient well. It needs to be transferred. So we're going to transfer the relationship of the socket and the foot, and maybe a knee if it's a above knee or a transfemoral level, to the new and final prosthesis that the patient's going to get. And we're going to use a jig, and this is a Hosmer jig or a vertical fabrication jig that's pictured here. And we're going to use that device to mechanically hold the relationship of the socket, the knee, and the foot, so we can take apart the pieces and parts of the prosthesis and replace them with the permanent ones, like the new socket and the new knee and the new pylon and the new foot that's going to go in there. So the transfer process is holding the dynamic alignment so we can transfer it to the new definitive prosthesis. So after that prosthesis has been transferred and the new prosthesis is fabricated, then we're going to go ahead and deliver it to the patient. And so you can see this one has cosmetics on it, and it's taken a lot of time and a lot of effort to get there. If we hadn't gone through this process and skipped the dynamic alignment portion of it, we'd end up with a prosthesis that looked real nice but probably didn't fit and function well. So that's the whole purpose of this whole process, is to get a good-looking, cosmetically appealing prosthesis that's going to fit and function well for the patient. The rest of this lecture is going to be over bench alignment. And so the rest of this lecture is not going to deal with casting, dynamic alignment, transfer, or delivery. It's just going to deal simply with bench alignment. So this is the phase we're in right now. Many students get confused while they're in school about what part of the process are they in. Once you get out into the clinical setting, you're going to find that this becomes natural and you understand the process very quickly because it happens over and over again every day and every week. But while you're in school, it's a little bit difficult to simulate because it takes a lot longer to build the prosthetic devices in school than it does out in the real world. Just kind of study this and watch the videos when you're done with this lecture. So here's our bench alignment specifications. And specifications for bench alignment depend on a few things. First off, on the components that are used. So manufacturers are going to have components that they have bench alignment values for. And then you're also your patient. So different patients will need different bench alignments. So the first thing we're going to talk about is limb length. So if the patient has a different limb length, it may change the type of bench alignment that you have to do a little bit, but that's kind of an advanced thing, and we're not really going to get into that today. But just know that shorter limbs and longer limbs have different alignment values to them usually. Then we have contractures. So sometimes a patient can't straighten their knee out all the way or can't straighten their hip out all the way. And in that case, we have to make adjustments for that deviate from the standard bench alignment for those special cases. And you'll learn more about those when you go through your laps and work on your class projects. And then we have types of prosthetic feet, or the type of prosthetic foot that you're using. And that, of course, is issued by the manufacturer depending on the foot that you have. And then we have prosthetic knees, so different knees have different alignments. And then socket designs. Some socket designs require different alignments. And again, that's a fairly advanced thing that we're probably not even going to focus on during this course. It can be somewhat more of a practitioner type of a subject to go over. But just it's good to know that socket design can change your bench alignment. Okay, so we're going to go over and kind of break down a transtibial bench alignment. And the first thing we're going to talk about is the sagittal plane. It's best when you're thinking about a bench alignment to break it down to the sagittal plane, the frontal plane, and the transverse plane. So the first plane we're going to do is the sagittal plane. And for this, we're going to have to first set the heel height. So not all shoes have the same heel height. We may have a shoe that has no heel height at all. We may have a shoe that has a 1/2 inch or a 1 inch or 1.5 inch heel to it, and we have to adjust our bench alignment for that. And to do that, we're going to place a block underneath the prosthetic foot, because prosthetic feet are manufactured to fit one specific height of heel in general. There are a few out there that are adjustable, but for this learning experience, we'll just say that they're made to fit one heel height. And there's also socket flexion, so we have to flex the socket 5 degrees, and that's just a standard bench alignment value. So you can see this is a vertical line right here. Well, this vertical line and the anterior of the tibia here, they shoot off on a little bit of an angle. So this is about 5 degrees of flexion or anterior tilt of the socket. And then the height, of course, and we need to set the height from the MTP level. The MTP level is right below or distal to the patella or kneecap, and that is where we're going to measure from that point down to the base of the heel. So we're not going to measure all the way to the floor. We're just going to measure to the heel and not down here to the floor. Now that's going to be confusing because most of your measurement forms say MTP to floor or PTB bar to floor. And that always confuses students because they want to measure down to the table, assuming that's the floor. The thing to remember with that is the practitioner is taking the measurement most likely without a shoe on, and the heel is touching the floor, and so it's the same distance. But when we add the heel height in there, we have to raise it up and add that heel height in to the measurement. So we always want to measure from the heel of the prosthetic foot to the MTP level when you're measuring for height. And then we have the anterior posterior placement of the socket over the foot. So we have to figure out, okay, we're going to put the socket here or way back here or way up here. Where's the socket go? So to figure that out, we're going to find the ankle bolt of a standard satch foot and make a line 1.5 inches anterior to the ankle bolt, and then run that line directly up, vertical, to the center of the socket at the MTP level. So that would be right here, straight down, 1.5 inches anterior to the ankle bolt. Now, for this purpose of this demonstration, this is all going to be standard satch foot values, and these are the ones that you can find in many of the orthotic or many of the prosthetic manuals, and I'm going to indicate those with asterisks and blue letters. So if they have asterisks and blue letters, these are the standard values for setting up a transtibial bench alignment. Okay, I'm going to switch over and go to some paper here and actually draw and do a bench alignment on paper. Okay, when we do our bench alignment, we need to first set up our foot. So, seems a little bit out of focus. Let me see if I can focus. I guess that's as good as it's going to get. So this black line is going to represent the floor. This black area here on the heel is our heel height, and this is the bottom of our heel right there. So if I place this foot with the ankle bolt, it should be right here on this line here, that would be a nice setup for a sagittal plane view of the foot. So if you look here, the top of the foot is parallel to the floor, maybe leaning slightly about 2 degrees anterior. When you're setting these up, the heel, the satch foot, remember this has a satch heel in it like this, and when the patient steps on it, it's going to compress, and as it compresses, it's going to tilt the pylon posterior. So it doesn't hurt to have about 2 degrees of tilt to the top of the foot when you're setting this up. So that's the first step, is to place the foot in there. I'm also going to make a line here 1.5 inches anterior to the line I just made that goes through the ankle bolt, and that'll represent my anterior placement of the socket over the foot. So done that, put my foot back down. You can see that this line is 1.5 inches anterior, 1.5 inches. Okay, so that's pretty good. And now I need to figure out my height, and the practitioner has written down over here that the MTP to floor is 19 inches. So I'm going to measure up, not from the floor, but from the bottom of the heel, 19 inches. I'm going to take my ruler here, measure up 19 inches. So that's going to be the MTP level. MTP level up there. I've got a little cutout of a socket here. And in the sagittal plane, I need to place this so the MTP level of the socket is 19 inches above the bottom of the heel. So I'm going to take this, and this right here, this dot right here, is my MTP level. So I'm going to place that right on that big red line that I made across there. Now, the MTP level corresponds with this little dip, and this dip's called the PTB bar usually, and this is the popliteal area back here. If you draw a line straight down through the socket and you place this vertical, that would be 0 degrees of flexion. Well, our standard value is 5 degrees of flexion, so we want to tilt this about 5 degrees. So you can see we're changing that, and we're giving it about 5 degrees of flexion into the socket. Okay. So after we have that done, we actually have the relation between the foot and the socket set. So we have 1.5 inches of anterior placement over the foot from the ankle bolt. We have the correct height set, we have the flexion set, and we have the heel height established down here with about 2 degrees of anterior tilt of the foot. So we've pretty much got everything in its right place. Now we just have to have a way to hook that together. And we use the pylon system to place this on top of the foot and then connect the socket to the foot using these components. So this pylon, you can see I've placed on here vertically. I haven't placed it so it's tilted posteriorly or anteriorly, but it's vertical, and that's important. And then we've placed our socket attachment block here, and then what we do in the real world is we just go ahead and just foam the difference between here and just fill this area with foam to bond the socket to the attachment block. And so that would be a properly bench-aligned prosthesis in the sagittal plane. So we have 5 degrees of flexion, 1.5 inches of anterior placement to the foot bolt, and we have our 5 degrees of flexion also. now we're going to go to some of the frontal plane bench alignment values. And first we're going to have socket adduction and abduction. The standard is 5 degrees of adduction, which is adduction, so that's in towards the midline. So if you look at this picture, you can see that this socket is tilting in towards the midline. This is the medial side over here, and it's kind of running on this type of a axis. And then we have an inset or outset of the foot, and the standard is 1/2 inch of outset of the socket. So we're going to take the socket and we're going to outset it 1/2 inch. So the foot's going to be closer to the midline and the socket's going to be farther away from the midline. And this is just a standard value they use for the frontal plane alignment. So I'm going to go ahead and do that on the paper here with you now. So with this is looking from the front of the patient. So this would be a frontal view. We're going to have our foot here, and again we have our heel height block underneath here. So we have our 1/2 inch heel height built into it. We are then going to go ahead and take our pylon and have that going straight up or vertical. And then we'll have our attachment block, of course, just like on the other one. And then we have our socket here. Now this is the medial side and this is the lateral side. So viewed from the front, this would be a left leg or a left prosthesis. And again, we'll have to set the height, bringing that straight over from the other one at the MTP level. And then we need to adduct the limb. So we're going to adduct it or bring it in about 5 degrees while keeping the center of the socket on this line. So that's great. Now the way this is, there's no inset or outset to the socket right now. We need to bring the socket out to the lateral side so the prosthetic foot is closer to the midline. So what we're going to do is we're going to bring this over 1/2 inch, and I'll go ahead and draw that line in there for you. So I'm going to bring this over. Well, 1/2 inch. So I'm going to go ahead and just place these back on the paper here, and then we're going to adduct this 5 degrees, adduct it 5 degrees, and then we're going to slide it lateral like this. So it's 1/2 inch outset to the center of the heel back here. You can also use the center of the ankle bolt. Either one, center of the ankle bolt, center of the heel, works out pretty well. So if we just drop this line down, the socket is now outset 1/2 inch from the foot. So the foot is closer to the midline. So if this was the middle of the body, this would be the midline right here. Line here. And this would be the lateral side over here. So the other foot would be over here, and this foot would be here. And this is 1/2 inch outset, set the correct height. And that's really all there is to the frontal plane. It's a fairly easy one to set, as long as you get your 5 degrees of adduction and your 1/2 inch of outset to the socket. Then finally we have the transverse plane. The transverse plane is over your head. So if you're looking down on top of somebody's head and you're looking down, that's how you view the transverse plane. And that's going to be your socket rotation. So there's a certain amount of toe out that everyone has, and the typical standard toe out is 5 to 7 degrees of toe out. And when we look at the socket, if we take it and we kind of divide the posterior of the socket back here and the anterior of the socket where the patella would sit, and we kind of draw a line from this point to this point right there and connect it, we want to place that line on the line of progression, and that line needs to be parallel with the line of progression. So once you place the socket parallel with the line of progression, all you need to do is place the medial border of the forefoot and the heel on the line of progression also, and that's going to reference whether the patient has a toed in or a toed out gait. So if he has a toed in gait, this foot would be pointing more over to the medial side. If he has a toed out gait, which is more natural and normal, it would be pointing more to the lateral side. So in this case, the patient has a fairly standard amount of toe out, which is about 5 to 7 degrees. And to set that, we are just going to use the medial border of the forefoot to do that. Okay, so this line is going to represent our line of progression, and this would be the left side, and that would be the right. And the line of progression is just the line you'd walk down those. So it's sort of the direction you're walking. So if I'm walking right down the middle of a road on a yellow line down the center of the road, that yellow line is my line of progression. So when I go to set my toe out, I'll use this prosthetic foot here. It's only half of a foot, but it'll work. This is the medial border of the foot. And this cut line that's cutting the foot in half here would kind of represent the center of the foot. So if this is parallel with the line of progression, that would be 0 degrees of toe out. So that would be 0 like that. Now, if we go to put it 5 degrees of toe out, what we're going to do is we're going to bring this medial border of the foot over and to the line of progression. You can see how that angles that line now. And now this line is actually at about 5 to 7 degrees of toe out. So if the medial border of the heel and the forefoot by the metatarsal head is parallel or on the line of progression, we're automatically going to have about 5 degrees of toe out. Now let's, so that would be just your standard bench alignment, and it can vary. You know, some patients have more toe out, some people have less. Now on the other hand, if the patient had toe in, it would be like that. And that's a very odd situation. The prosthesis probably wouldn't function very well if you had the foot toed in. So standard bench alignment value is 5 to 7 degrees of toe out. So by placing the medial border of the heel and the forefoot on the line of progression, you automatically have established your 5 to 7 degrees of toe out. And that's in the transverse plane. That's all the different values you have to set for your basic bench alignment. This video is kind of short, but it kind of goes through the steps of bench alignment, dynamic alignment, and then fitting of the final prosthesis. It goes through very, very quickly, so I'd suggest that you do go ahead and view the longer version that's more detailed on your Blackboard account. Okay, so that video was over, it actually didn't show the bench alignment process, it just showed the dynamic alignment process and then the transfer, and then the patient in the end was walking on his definitive prosthesis. That was a little bit different because there's not a lot of components to that. It was what's called a monolithic design, so there wasn't a lot of components to be transferred. It was all built into one piece for the final or definitive prosthesis. If you have any questions about the bench alignment of a transtibial prosthesis or any of the steps to delivery of a prosthesis, feel free to talk to your instructor.